Hello and welcome to another Earth Science podcast. I'm your host, Mr. Buss, and in this podcast we'll be discussing what climate is, and might even talk about what it is not. So the first slide here, climate is what you can expect in an area for the average of weather over a long period of time, and the average is typically taken as 30 years. So to help clarify that, you might hear on a weather report that today's temperature was 74 degrees, and that's 3 degrees above average. That's the last 30-year averaging of temperature for the area. It's not the average of all temperatures ever taken for the area. So climate isn't just how hot can it get. Now that is part of it. Air temperature is part of the climate conversation. But so are other things like humidity or how much water vapor is existing in the air. Because in Minnesota in the summer, when it is hot and humid, it feels a lot different than if it's hot and dry. Wind speed and direction. So where's the wind coming from and how fast is it going? The type, quantity, and frequency of precipitation. So you can't just say how much water do you get. Well, do you get snow? Do you get ice? When do you get it? Does it come all year round? Here's what we're going to see for Minnesota here. But does it come as a rain for monsoon for a couple months and then nothing for the rest of the year? So how much rain do you get? When do you get it? Is it snow? Is it ice? Those kinds of things affect climate as well. Here in Minnesota, we've had some pretty fantastic April snowstorms. Fantastic depending on your point of view, I suppose, but it's been a snowy April. Climate can change but only long periods of time. Global climate is not the temperature outside you're experiencing today. So a lot of times, I'll hear comments like, well, so much for global warming. You're taking, I get it. It's kind of a funny thing to say when it's cold out and you're expecting warm. But the global climate is not what temperature is it outside today in your little part of the world. Climate and today's temperature, it's not the same thing. So factors that influence the climate, well, obviously, how close are you to the equator, right? Because the equator is receiving the most direct sunlight, so you're obviously a lot hotter at the equator. Another thing that can influence climate is where are you in relation to atmospheric circulation cells, the Hadley cell, Farrell cell, and polar cell. Is warm, moist air rising and causing precipitation, or is dry, warm air falling and causing a lot of deserts and so on? So where are you in terms of the circulation cells of the Earth? Here's the intertropical convergence zone. You can just see that warm air rising there and the humidity in the air as well. So where you are in terms of proximity to the ocean makes a big difference as well. For example, if you live in Wichita, Kansas, you've got a January low of 20 and a July high of 92. So if you take the difference between those two, you're going to get a difference in temperature of 72 degrees between January and July. If you're living in San Francisco, California, you're right by the coast. And so you're looking at that, well, the difference between 46 and 66, the January low and the July high, is only 20 degrees. So between the two of those, that's a difference of 52 degrees, whether or not, for the high and the low. And that's basically because Wichita is in the continent and San Francisco is near the ocean. Well, why is that? Well, because the ocean is moderating. In the summertime, the ocean is cold, and so it is keeping San Francisco cooler. It's not cold, but it is cooler than the land in the summertime. In the winter, the land is very cold, and the ocean is relatively warmer, and so the ocean warms the land in the winter in San Francisco. So you get a moderate climate near the ocean, as opposed to in the center of a continent. All right, so ocean currents also affect climate. And if you look just specifically at the Gulf Stream, I think this is just amazing that more than 100 times the world's energy demand is actually just stored in that warm water of the Gulf Stream. And just think about, that's just one ocean current, and there's many. The Gulf Stream basically heats the air that blows over it. So as air blows over the Gulf Stream, it's going to warm up. And this affects London because London is receiving warm air that is blown over the Gulf Stream. So London's average January temperature is cold, 38 degrees Fahrenheit, but not nearly as cold as Quebec's, which is 10 degrees Fahrenheit So London's above freezing, average in January. Quebec is below freezing at 10 degrees Fahrenheit in January. Why? Because the air that flows over the Gulf Stream picks up a lot of water, and so London gets a lot of rain, and it also picks a lot of heat. So London's a lot warmer than Quebec. Altitude, right? If you go climbing up a mountain, it's going to get colder the higher you go. Air pressure and density both go down. All right, so which direction is the air blowing over this mountain? To me, it's looking like it's definitely going this direction. As the humid air is carried up over the mountain range, the air is hitting the dew point, and so all the precipitation is falling on this side of the mountain. All right, and then once the air rises over the mountain, it's lost its precipitation, and you're going to have desert on the other side of the mountain there. So which side of a mountain range you live on and which direction the air blows over that mountain range can also affect climate. And that's going to conclude this podcast. Thanks for joining me, and I'll see you next time.